GMAT all day.
In this video, we will be talking about average speed questions. Like catch-up problems, I like average speed questions. I think that they are on the easier side of rate questions. The one thing that you want to make sure of, though, is that you are thinking about average speed in the right way. There is a common mistake that I see people make that you want to avoid. And so let's take a look at that. So let's do that by making an illustration. Let's say you got someone is going from place A to place B, and we will say the distance between A and B is 10 miles. So let's say we cut his trip in half. So for the first 5 miles of his trip, our guy is walking at a rate of 3 miles per hour. And then for the last 5 miles of the trip, he jogs at a rate of 5 miles per hour. And I was to ask, what is his average speed for his trip? And so what the people usually say is that, well, he is spending the same distance at each of these two rates. Therefore, I can think of them as just being a simple average. In other words, these two rates, they are weighted the same. And so I can just take their simple average, and his average speed should be just 3 plus 5 over 2, which is 4 miles per hour, which sounds like it is a reasonable average speed. It is also wrong. And why is this wrong? And so this approach here, where you are treating average speed questions like they are weighted averages, and you can actually do that. You just have to make sure that you weight them in the correct way. So what these people are doing is they are weighting their rates in terms of distance, which you actually should not be doing. You should be weighting your individual rates by time. So even though he does spend the same distance at each of his two rates, when he is going slower, when he is going at 3 miles per hour, he is actually spending more time at this rate than this rate. And when he's going faster, when he's going at 5 miles per hour, that causes him to spend less time at this rate than this rate. And so this is a bit paradoxical, but the smaller rate, the slower rate, is actually weighted more than the faster rate because he is spending more time at that rate. And so in this case, our actual average speed should be a little bit less than 4, because it should be a little bit closer to the 3 than the 5. And so the way that I always ensure that I don't make this mistake, so you can do average speed problems as weighted averages. You just have to make sure you are weighting them by time, or you can just always think of average speed as being total distance over total time. That is usually what I do. That simplifies the thinking that I have to do. So in a case like this, what would his average speed be? So we said 4, we can sort of estimate it. It's going to be a little bit less than 4 because it's going to be weighted more towards the 3. So I don't know, it should be something like 3.8, we will say. But let's actually find it now. And so total distance is easy. We know the total distance, he traveled 10 miles. Now the total time is actually going to be the sum of the times for the 2 legs of his trip. So those are what we need to calculate. And to do that, we can just organize the information in a table like we have been. Up here we have the first leg of his trip and the second leg of his trip. Each of our 2 legs are 5 miles. And here's our T1, here's our T2. And so for the first leg of his trip, his rate is 3 miles per hour. For the second leg, it is 5 miles per hour. Therefore, his T1 is 5 over 3. And his second time for the second leg of his trip is just 1. Unit here is hours. So 5/3 of an hour plus 1 hour. So this would be 5/3 plus 3 over 3. So that is 8 over 3 hours is his total time. So if we just plug that in here, so his total distance over total time, so he goes 10 miles in 8/3 of an hour, which is the same as 10 times 3 over 8, so that is just 30 over 8 miles per hour. And as a decimal, that is 3 6/8 miles per hour, which is 3 3/4 or 3.75 miles per hour. So pretty close to what we said here. But the real point is it is a little bit less than 4 because the 3 gets weighted more strongly than our 5. Let's look now at an average speed question that is more of an actual GMAT question. A monorail traveled from Brockway to Ogdenville at an average speed of 120 kilometers per hour, and then from Ogdenville to Springfield at an average speed of 100 kilometers per hour. If the monorail did not stop at Ogdenville, what was the average speed at which the monorail traveled from Brockway to Springfield? So if we start organizing the information, so we got 2 parts to our trip. First, we got to go from Brockway to Ogdenville, and then Ogdenville to Springfield. Then we want to combine these just into a single trip from Brockway to Springfield. And all we know are the rates for the 2 components of our trip. And so I am looking for, this shouldn't be work. We're now talking about distance. I want to find total distance over total time. And so how you write that is sort of up to you. I maybe won't fill it in yet. I'll wait till I get some actual values. But for example, if you want to call each leg of the trip D, and then his total distance would be 2D, or if you want, you can call each leg of the trip. If you knew, for example, each leg was the same distance, if you want to call each of those 1/2 D, then his total distance would just be D. You can do that. But for now, we don't really know anything about our distances. And so look at our statements. This is all we can fill in. But I do know what I'm looking for. Total distance over total time. That does not necessarily mean I need both my total distance and my total time. But I can get one in terms of the other, so that I can write this as just if I know my time is equal to 3 times my total distance, and I get D over 3D, and that D cancels out, that will be good enough to solve for my average speed. So statement 1 says the distance that the monorail traveled from Brockway to Ogdenville was 1/5 the distance that the monorail traveled from Ogdenville to Springfield. And so maybe I will put this, if I can put this in terms of a non-fraction, I would prefer that. So saying the distance from Brockway to Ogdenville was 1/5 the distance from Ogdenville to Springfield. That's really the same as saying distance here, this is D, I'll call this 5D. Now this makes my total distance 6D. And so that is really what I care about. Now remember, so now I got to find my total time. I can still think of that as just being T1 and T2, but that doesn't mean just because I can't solve for T1 and T2 that I can't find my average speed, especially if I can get them in terms of my distance, which I can, because so my T1 is really just D over 120. D is kilometers, D kilometers. And my T2 should be 5D over 100. Really just D over 20. So my total time, so now if I were to looking for average speed, that would be total distance 6D over my total time, so T1 plus T2, which is D over 120 plus D over 20. Now, whenever you see that this is going to be sufficient, you can sort of stop, because I can sort of see now that I have everything in terms of D. Therefore, once I combine my fractions in my denominator, that D should cancel out. Let's go all the way though, and just get an actual value for our average speed. So our average speed is equal to 6D over D over 120 plus D over 20, which, so if a common denominator here would be 120. This is 6D over 70 over 120 equal to 6D times 120 over 70, and these cancel out. Average speed is 720 over 7 kilometers per hour. And I don't know what that is. Looks like it's a little bit more than 100, which makes sense. And so statement 1 is sufficient. B, C, and E are out. Statement 2 says the amount of time that it took the monorail to travel from Ogdenville to Springfield was 6 times the amount of time that it took the monorail to travel from Brockway to Ogdenville. So in this case, they're giving me information about the time, not the distance. And so rates the same, 120 and 100 kilometers per hour. The amount of time that it took the monorail to travel from Ogdenville to Springfield, so that is this time here, 6 times that it took here. So if I say this is t, for example, and this is 6t, so now in terms of, instead of getting everything in terms of d, let's see if I can get everything in terms of t. And then instead of the d canceling out, we'll have a t cancel out. So my distance is here. I can just multiply across. So my distance from Brockway to Ogdenville should be 120 t. My distance from Ogdenville to Springfield should be 100 times 6t, 100 t. Now that I see I'm getting similar numbers to before. So again, whenever on your actual test, you see it will be sufficient, you can move on. Let's do this to completeness. Because again, when it is on a data sufficiency question, when it's easy to actually find the final answer, sometimes it's helpful to do so because your data sufficiency answer choices, they should never contradict each other. So should never have a case where statement 1 says x is equal to 3 and then statement 2 says x is equal to 2. So if that does happen, the answer is still probably D, but you made a math mistake, but you can use that as a check. And so here our total distance is 720t, our total time is just 7t, and therefore our average speed is 720t all over 7t, which is 720 over 7. Same thing we got before. So note for each of our statements, we did not find the actual value of our total distance or the actual value of our total time, but we were able to find the total distance over our total time by getting one in terms of the other. The answer here is